Okay, folks, welcome back. We're still doing vectors higher examination questions. Question number 21. Ismail's going to join us on this question. Okay, Ismail, let's go. Right. Read from the top, please. Always read this part here. What's the part here say?
Diagram not accurately drawn.
Which means?
Don't measure it with a ruler.
Excellent. Now, let's go straight into the question. Let's go. Read.
The diagram shows two triangles, OAB and OCD. OAC and OBD are straight lines. AB is parallel to CD. O to A equals A and O to B equals B. The point A cuts the line OC in the ratio OA. Ratio of OC equals to 2 to the ratio of 3. Express CD in terms of A and B.
Okay, lovely. So now we've got another ratio question. Okay, O to A and O to C. So can you please interpret that ratio for us, please? How do we do the ratio question?
Do 2 plus 3 is 5 parts. And it's going to be,
so you wanted me to do 2 plus 3
fifths.
is equal to 5.
Yeah.
So the fraction,
Over 5. It'll be something over 5.
Okay, right.
Okay.
Does everybody agree that that's the way that we should do this particular question? Okay, now, the reason why I asked that question is this ratio is different than the previous ratios. So it's O to A, and then it's O to C. So the ratio starts from O to A, and then O to C. In the previous question, let me just take it back up here.
It's from the common point.
Not just common point. In the previous questions here, the ratio has always been X to P, and then P to Y. It's a continuation.
Yeah.
So that's how those vectors have worked out to give you fifths. X to P, and the P is doubled in the middle because it's restarting from P. Now, if you look at this question that we're about to do now, so what you've done this, it's not a unpopular mistake, it's a common mistake. Now look here, you're going O to A, and then you're doing O to C. So it's not actually a 2 to 3 vector. It's actually, does anybody know what the vector actually is then? It's not 2 to 3.
2 to 1.
2 to 1, beautiful. So well pulled back there. So the vector is actually 2 to 1 because you have to interpret where the vector starts from.
All right, yeah.
So that's not a problem. Making mistakes and thinking something is something else is part of learning math. So that's fantastic. The most important thing is you're able to pull the question back from where you took it. So 2 to 3 ratio does not mean 2 add 3 equals 5. It doesn't mean that. It actually means 2 add 1. So we've got 3 parts. Okay, now, and also we have to do a little bit slightly different as well. So I'll be happy with the labeling now, Ismail. So so O to A is 2, and then the A to C has to be 1 because altogether is 3. Are we happy with that labeling?
Yeah.
Okay, beautiful. Okay, now that will help us a lot. Now, remember, if you got 2 triangles like this, these are called what also? They're called?
Similar. Aren't they also known as congruent or something?
Congruent would be if they are identical to each other. OAB and OCD cannot be congruent. It's impossible. One's small, one's a bigger version of the small one. Now, one thing you have now you have to be a little bit careful now. The original shape has a length of 2, and then the new shape becomes 3. So what's the scale factor? If you want to do a scale factor, what would the scale factor be? How does 2 become 3?
It is 1 by 1.5.
1 by 1.5. Okay, lovely. So, give me 1 second. We'll come back to that in 1 second. So, express C to D. Now, let's look carefully at what we have here.
So,
so hang on 1 second.
So
2 parts is worth what?
A. So, would 2/3 of A to C equal A?
No, we're not doing 2/3. Just leave it to what we can see there on the diagram. 2 parts is worth A. So what's 1 part going to be worth then?
Half A.
Beautiful. Fantastic. So the bottom part here will be what?
A over 2, yeah, half A.
Now, this is another reason why we have to look at this again. Diagram is not accurately drawn. Does the bottom piece that I've labeled half A look like half of A?
They look fairly around the same.
Exactly. So you could tell us, oh, hang on a second, sir. Half A doesn't look right. What am I going to point at?
The top right, yeah. The
top right-hand corner, diagram not accurately drawn. So even though the diagram looks physically the same size on the bottom as the top, and we've labeled it mathematically half A, you can't use the argument, oh, it doesn't look half A, because they're telling you in the beginning nothing looks like what it's supposed to because not drawn to the right scale.
Yeah.
So that's a second very, very phenomenal reason why you should always remember, don't look at sizes of something. Oh, well, it can't be half A because it looks the same size. It must be 1A. I must have made a mistake. So don't doubt yourself in the examination. So lovely. I like that. So similarly, this is B. What will this part over here be then?
Is it a half B?
A half B? Does it look like half a B?
No.
It doesn't. You look like bigger than B.
Yeah.
Okay, lovely. So, because that's the scale factor. Now, lovely. So the bottom part is half the size of the top part because of the ratio of 2 to 1. Now we should be in the position that we can do the question. Okay, right. Now you go C to D. So I need you to take me from here to here. So Ismail, can we go straight across? Can I do that?
No.
No, let's go to that. Which way do you want me to go then?
C to A to O to O to B, then B to D.
Fantastic. Let's write that down. C to D, it'll be, so first of all,
C to A.
it'll be C to A.
The half minus a half A because we're going in the opposite direction.
Beautiful, because that vector is going down and we're going back up. And then plus what?
Plus A.
Plus A to O.
Oh yeah.
Which will be minus A because A is going down and we're going up. Excellent. And then we're going to go which way?
Downwards, so it's the normal one.
So O to B, so it'll be plus B, it'll be plus what you see there, lovely. And then we're going to go from B to C. And then?
Is the half B.
Lovely. And then what can we do now?
And simplify it.
Okay, so you got the A terms are here and the B terms are here. So go on then, give me a simplified answer.
Would it be a half A plus?
Be careful, you got minus half A and another minus A.
You have to make it the same denominator.
Just do it as like you got minus half an apple and minus one apple. Like algebra, minus half A, minus one.
Yeah.
So doesn't that give you, yeah, one? Does not give you that?
Oh yeah, as a mixed fraction, yeah.
Yeah, it's a mixed fraction, yeah. You do mixed fraction, top heavy fraction, doesn't matter.
Yeah.
And the next one now, do the next one for me.
Plus 1/2 B.
Lovely. So if you want to